Hi everyone and welcome back to chemistry. This is Mrs. Hutchinson and we're going to continue our discussion with the history of the atom. We're finally going to finish up talking about isotopes. So isotopes, again, a little bit of a recap. Remember, they're atoms of the same element that differ in numbers of neutrons. And the atomic masses that exist on the periodic table represent the average of all of the naturally occurring isotopes that exist for that particular element. So if we take a look at fluorine, this atomic mass represents the weighted average of all of the naturally occurring isotopes of fluorine. In other words, it tells us which one is probably the most abundant, the one that's closest, the whole number that's closest to our average given to us on our periodic table. So for fluorine, the most abundant isotope would be fluorine-19. But what we can then do is we can figure out how to calculate the average atomic mass of an isotope's atoms if the percentages of the isotope's abundances are actually known. So, in other words, if we're given the percent abundance of each isotope, we can determine the overall average atomic mass of that particular element. So, before we get into this, I want to really discuss, well, what is a weighted average? So don't necessarily write any of this down on your notes because you're not going to have enough room. So make sure you just pay attention and listen here. So what is a weighted average? You deal with weighted averages all the time. You just don't know it. So in this particular class, your average is a weighted average. You've got your tests, your quizzes, you've got your labs, and your homework. And I'm just going to give you some numbers here. So test, quiz, lab, and homework. So let's just say that I didn't give you a weighted average. Let's say that everything was worth the same amount percentage-wise. All of these were worth 25%. Well, some of you might actually like that. That would be pretty good. So if they're all worth 25%, let's say that your test average was 85. Your quiz average, 87. Lab average is 92, and your homework average is a 98. Well, let's figure out what your actual average in this course would be. So how do we go about doing that? We take our percentage, we make it a decimal, multiply it by the number that we're looking at, and then we simply add them all together. So when we actually do all of that math and multiply 0.25 times 85 plus 0.25 times 87 plus 0.25 times 92 plus 0.25 times 98, we come out with an average of 90.5. Not too shabby. But actually, how your grade is calculated in this class is not that everything is even, but rather your tests are actually worth 35%. If I can write 35 as opposed to just 3, because I think a lot of you would like it if it was just 3%. 35%. Your quizzes are worth 30%. Your labs are worth 25%. And your homework is only worth 10%. This is what I mean about a weighted average. Not everything has the same value or the same weight. Tests and quizzes are weighted much more heavily than labs and homework. So now if we take those same values, those same numbers, our 85 on our tests, our 87 on our quizzes, our 92 on our labs, and our 98 on our homework, again, we'll take all of our percentages and we'll make them decimal percentages. And we're going to multiply them and add them up. So 0.35 times 85, 0.3 times 87, 0.25 times 92, and 0.1 times 98 would give you your actual average for this course of 88.65. So because our tests and quizzes are weighted much more heavily, it's going to bring your average closer to what they are actually valued at. So that's what a weighted average is. So what we're going to do is apply that same principle for calculating the weighted average or average atomic mass of our particular elements. So what is the average atomic mass of an element if we have 20% of the atoms that have a mass of 176 AMU, 30% of the atoms have a mass of 177 AMU, and 50% of the mass of the atoms have 178 AMU. So, let's go ahead and do this. So we've got 20% that have 176, 30%, 177, and 50%, 178. So, again, when you take your weighted average, what you're going to do is you're going to take your decimal percent and multiply it by the mass of that particular atom. So we've got 20% to make it a decimal percent, because percent means per 100. We're going to move the decimal 2 places to the left. So we're going to get 0.20 times 176 plus our 30%, which will move to 0.30 times 177 plus our 50%, that becomes 0.5, so 0.5 times 178, and we just do all of that math and we simply add them together, and you will get your final answer of 177.3 AMU. Okay, so that would be how you will set up all of your calculations for calculating the weighted average of your isotopes. So now, you better believe, we do have a worksheet. It's going to discuss, it's called the weighted average of isotopes. So, taking a look here, you're going to use that example that we just went over and determine the average atomic mass of these particular isotopes. Things you want to be aware of. Just because it might look like these are already in their decimal percents, they're not. It says that we have 0.2% of the isotopes weigh 36 AMU. That means it's 0.2%. We haven't moved it yet to our decimal percent, so you still have to move the decimal 2 places to the left. So go ahead and use that example to help you. Once you've completed this worksheet, you can then begin to work on the review packet for this particular portion of Unit 2. It looks like this, so it's review and assessment questions of our Unit 2. It starts with what is an atom, and then what are the limitations of Democritus's ideas, and so on and so forth. I also have them up on the website with the answer key so you can check as you are going along. If you have any questions, feel free to ask me. That's what I'm here for, and I will see you for our next video.